Okay, 22. There are only R red counters and G green counters in a bag. A counter is taken at random from the bag, and the probability that the counter is green is 3/7. So let's have a look at what that situation looks like. We have a bag, and we have R red counters. So R stands for the number of reds, and G stands for the number of greens. And we know that the probability that it's green is 3/7. Okay, the counters put back in. 2 more red counters and 3 more green counters are put in the bag, and the counter is taken at random. The probability that the counter is green this time is 6/13. So what that's actually telling us is, in this bag there were R red counters. Now there's however many reds there were plus 2, and you've got the number of greens plus 3, and the probability that it's green now is 6/13. Okay, so to work this out, first of all, let's write this as an expression. What is this actually telling us? The probability that it's green will be the number of greens out of the red and greens, which will be 3/7. The probability that it's green in this bag, however, will be however many greens, so that's G plus 3 over R plus 2 plus G plus 3, and that equals to 6/13. Now what we've got here is 2 different scenarios, and what we need to do is rearrange these so that we can make simultaneous equations out of them. The simplest way to do that would be to cross multiply. So if we multiply that way, 7 times G is 7G, 3 times R plus G, don't forget to include the brackets here, and the same can be done here, so 13G plus 3 equals 6 times this, which can be simplified into R plus G plus 5. Okay, if we multiply those brackets out and simplify, 7G equals 3R plus 3G, and if we subtract 3G from both sides, what we end up with there is 4G equals 3R. I'm going to leave that as it is there, and on this side 13 times G is 13G, 13 times 3 is 39, and on this side you've got 6R plus 6G, and then you multiply by 5, which gives us 30. If we neaten this up, so if we subtract 6G from both sides, you get 7G. If you subtract 39 from both sides, you get minus 9. And if you subtract 6R from both sides, you get 7G minus 6R. Now we've got an equation here, an equation here. And what you can do, what would be the simplest way is to, if we put it in as we normally would do with simultaneous equations, so 4G minus 3R equals 0 in that case. So minus 3R equals 0. And what we can do is we need to make sure one of the coefficients, either make both of these into something that they both go into. In this case that would be 28, or we can make these both 6. That would be the simpler way, by multiplying that equation by 2. So if I multiply this one by 1 and this one by 2, we get 7G minus 6R equals minus 9 as it was. And then this one multiplied by 2 gives us 8G minus 6R equals 0. And then in order to nullify these, you've got to subtract them, because minus 6 minus minus 6 will give you 0. So if we do that upwards, it might make a bit more sense. 8G minus 7G leaves us with 1G. Minus 6R minus minus 6R will leave us with 0R. and 0 minus minus 9 leaves us with positive 9, so we're left with G equals 9, and that bit will tell us how many green counters there are. And we can use this equation here again. So if 4G is equal to 3R, and now that we know that G is 9, 4 times 9 is 3R. So 36 is 3R. Divide both sides by 3, you get 12 equals R. So there are 12 red counters and 9 green counters. And just to double check that this is definitely right, it's a little handy hint that you can use in your exams if you've got a little bit of time. According to this equation, the number of greens out of the reds and greens, so we said there were 9, so 9 out of reds and greens, which is 9 plus 12, simplifies to 9 over 21. And you can divide both the top and the bottom by 3, which gives us 3/7. So we can see that this one works. And just to double check it with this one to make sure it definitely works, if G is 9, then 9 plus 3 out of the reds plus greens, which is 21 plus 5, gives us 12 over 26, which simplifies down to 6 over 13. So again, we can see that that is definitely correct.